Now, like I said, the activity-based costing, see, direct material, you can easily trace that one. No need to worry about that. There is no costing involved in calculating direct material, direct labor, and this shipping cost, variable cost. It is already traced. The complexity occurs when there is an overhead. When there is an overhead, it is hard to find out. First, we go through the first stage allocation to find out the cost pools or cost activities. And then we have a second stage allocation in which we find out its activity rate. Right? Simple. So the words here are very fancy, but in basic mathematics term, it is very, very easy. You agree with me, Subhan, Pinyo?
Yes, sir.
Okay. Ali, welcome.
Yep.
Okay, so then we had our second exercise in our first class. So all things are given. So you see, you are given the activity Mayer, and you are given the cost pools here, right? So this is the cost pool, square feet of lawn. So this much lawn, so you divide it by this one, divided by this one, you find out the rates. Simple. See, activity rates. That is called the second stage allocation. If the question arises, find out the second stage allocation. First, you identify the cost pools. You multiply with the percentage using first stage allocation, and then you divide those cost pools with their activity rates, with their cost drivers. In the denominator, you find out the activity rates. Simple. That is simple. Right? Now, question arises, we have found the activity rate. How we can utilize those activity rates? What does it mean? How this will benefit us? Right? Here we go. Now, from here, we will be finding out assign cost to a cost object using second stage allocation. So we have find out the activity rates, and now we want to find out how costs are going to be associated. So we have two products here, and we want to find out how much it costs short start and how much it costs for long life. So there are two batteries that are made by Baxter battery. Number one, short start, which requires no design change, which means zero design change here. Number two, 800,000 batteries are ordered with 4,000 separate orders. So they receive 4,000 orders. Total batteries are required 800,000. See, so we have this base as well, right? And each short start takes 36 minutes of machine hour for a total of 480 machine hours. What does it mean? It takes 480,000 machine hours to complete 800 batteries, or one battery can be completed into 36 minutes. 36 minutes. Now their second brand is long life, which requires a design change. So design change activity rate gonna be applied here, right? 4,000 batteries are ordered with 6,000 separate orders. So per order change, we already find out that it's, I think, $452, right? 4,000 custom design prepared, right? Each long life requires 48 minutes of machine hour, or total 320,000 machine hours, which means it takes 320,000 machine hours to complete 400,000 batteries. So how we are going to find out the per unit cost of short start and per unit cost of long life? So we already have overhead rates, right? So we already calculated from the first stage and second stage allocation here. Let me clear this mess here. So customer orders per order 452. Design changes 750 or maybe 60, 760, right? So in short start, we don't have this because there is no design change required in short start. Order size, machine hours based on 6.5. So over there, how many hours? Everything is mentioned, customer relation mentioned. So let's talk about that. So for short start, no design change, so design change is gonna be 0. Design change is gonna be 0, right? Customer orders, 4,000 orders. See, this 4,000 orders, so 4,000 multiplied by its rate. So customer order cost 1.808 million. Order size, order size is based on machine hours, so 480,000 machine hours are used. So 6.5 multiplied by 480,000. Answer gonna be 3.12 million. So do we have to write down the customer relation because we don't have any information regarding the customer? Just orders are given. So no customer relation is there. So that's it. So total cost, total ABC overhead cost for Sure Start, 4.928 million. Similarly, with the long life, we have design changes. Yes. How much design changes? 4,000 custom design changes. Multiply by 760. Answer gonna be 3.04 million. Similarly, 6.5 into the machine hours, 6,000 customer orders are given. So here we go, 7.832 million. This is the product cost. Simple. First stage allocation, you find out the cost pools. You divide by with the cost driver. You find out the activity rates. You multiply by with the current activity. You find out the answer. So that is product cost. Now, what if we want to find out how much this customer cost us? Right? So let's just have this illustration. So now we are entering towards our today's agenda. Here we go. So let's take a look on the how Baxter battery system works for just one of the 2,000 customers. One of the 2,000 customers. It means the Baxter company has 2,000 customers. Among those 2,000 customers, one is Acme Auto Parts, who placed the following order. Following 12 orders, in which 8 orders belong to 60 sure start per order. So they gave us 8 orders. Each order contains 60 sure start. So total how many battery they require? 8 multiplied by 60. Right? 4 orders of 50 long life per order. It means 4 into 50. Answer 200. 480 is normal and 200 for long life batteries. And machine hours, they are already given to us. 480 sure start. So this 480 is coming from 60 multiplied by 8. This 480 sure start requires 288 machine hours. 200 long life requires 160 machine hours. All you need to do, multiply with the rates, find out. Here we go. So for at customer orders, he gave us 12 orders, right? One order cost $452. So this is the order cost. Design changes. So he only put 4 orders for lifelong in which logo change or design change are required. So you see only 4 here. Overall, he placed 12 orders. So, but only 4 belongs to design change. So we multiply with the 4 here. So order size 448, which means $448. 448. Total machine hours 448. So do not be confused where this 448 is coming.